So I'll introduce myself again. I'm Shrey Goyal. I'll be taking this webinar for you. And this webinar would be on advanced predictive modeling. So in meanwhile, talk about the entire module and what is this module about. I would request you to just give me your brief introduction on the chat window, on the question window, as in what's your background, how many years of experience you have, and are you into business analytics, or do you have a background of data science and business analytics or big data for that matter. So that, I'll be able to give you more references and more examples based on your experience, and you'll be able to connect it with your daily example. Right? Okay. So before we start this course, let me tell you what is this course all about. This course will talk about the most advanced feature of analytics, and moreover, this would be the final thing in your data science career. So this is one thing which would complete your domain knowledge of data science. So I guess you must have heard about regression, logistic regression. We'll go much beyond this. So I'll show you the PPT. So when we talk about this webinar, in this webinar we'll try to talk about what is predictive modeling. We'll go beyond predictive modeling and talk about ordinary least square regression. And we'll see that how a real life data set look like and what are the handicap of least square regression. Then we'll move forward and talk about different features of least square regression, problems, its shortcoming, the bottleneck, and so on and so forth. We'll try to see what is forecasting. So for example, you must have heard about forecasting tools and the pattern of forecasting. So if you have the sales, over here I say I have this data where I have sales data. Now how do I forecast? So in the sales data, which is say 10 today, 20 quantity tomorrow, 30 tomorrow, again 30 tomorrow, then 32, then 10, then 11. So what are the hidden pattern inside of forecasting data? A forecasting data is just forecasting data. It has a lot of things inside it. So we'll first understand how to build it. We'll try to decompose forecasting data and then try to understand how to forecast. So let me take you to the data set directly. So let's see first. So I'll take you to my R screen and we'll try to do something with it. So there's a package called data sets. So this data sets have n number of databases or basically data sets available where you can practice and experiment. So I'm taking a variable called A and I'm making a time series. Now what is a time series? A time series data frame is something where you have time across on one side, which is date, which is period, and on the other side you have something the numbers. So for example, if you have a set of variable which says date, so particular date, say 1st March 2014 and goes up to date till today, and you have daily sales record. Now how you will convert it into a data frame? So this is one called TS, which is called time series. It comes with a package called forecast. So now if I take this and what I did, so I'm taking 1 to 500 as data points. So 1, 2, 3, 4. I'm taking 12 frequency, let it be 12 month data. Start from the year 2011 and from the 3rd month of 2011. So the 3rd month of 2011 should be March. I hope so if I'm not wrong. So let's see what does R says. So R gave me a long list of data. Now let's see. How does it start on and from where does it start? So it's starting from somewhere a month, which is what? It's starting from March because I say 2011 3rd month, yes. So frequency is 12 because January to December is 12. And then start giving number 1, 2 and it will end at 500. So let's see the last value. The last value is 500. Now what if I make this, say I make it 4 and let's see what happens. So again I did something. So what happened in 4? Any guesses? Let's see. Again 5 number. So it breaks it into quarter. So 3rd quarter, so you start from the 3rd quarter and go on. So it breaks it into quarter. So that is how you can play with your data. However, I'll keep it 12 for ease of understanding. So this is my monthly data for say 40-50 years. To that sense, give me 500 sales point, and thus I have my time series data. Now see, is it actually a time series data? Yes. So it says a time series data 1 to 500 ranging from year 2011 to 2053, and the data and the sample of data 1, 2, 3, 4 and goes up to 500. Now let's see the attributes. So attributes talk about that it has class which is time series, and then it has years for that matter, and that is how a time series data is made. I also have a data set which talks about air passengers, that is air travel. So around a year, so let's see the data first. So it's again a time series data starting from 1949 goes up to 1961 and so on and so forth. We'll see the summary of the data. The summary of the data says that okay, the minimum data point is 104, goes up to 622 and so on and so forth. It has 144 data point. Now let's see the data. So this is how the data looks like. Starts from 112 and goes up to the data. Now what we'll do, we'll plot this time series data. So if you can see my screen, so across the year I've plotted the data starting from again 1949 goes up to 1961, and there is a increasing trend which you can see. But there are a lot of things inside this data. Let's see what's inside this data. So what I'll convert this data into a time series data, again frequency of 12 months. I'll convert it into decomposition. Decomposition is breaking the data into various. You can see that I have decomposed the data into various factors. Now what are these factors? So a time series data has a couple of components in it. So this is my time converted into a time series data, say 12 months and a couple of years, and then what I do, I break it into three parts. One is called seasonality, where you have, it shows that how it varies across season. Then there's a trend, how does the trend changes, and then you have randomness, that how the data changes randomly. So that is, what are the random components in time series. So the time series data, we understand there will be a trend component, there will be seasonality, and there will be random purchase behavior. So all these three are combined together to make a time series. Decompose command takes the entire things, break it into three different parts and present it in front of us. So what we have, the real data, we have seasonality, we have trend, and we have randomness, and type is additive or multiplicative. We'll come to that when we do the course. It's about additive is, adding, and multiplicative is multiplying the data points. Now what we'll do is we'll take a graph out of it. So this is how my graph looks like, but the actual graph should be something like this. So it gives the observed data. The observed data is broken into the first trend component, and then the seasonal component taken out, and then the randomness is taken out. If you take these bottom three blocks, combine them together, get your original data series. So that is how things are broken into different parts. Now the second thing is called ARIMA modeling. Now what is ARIMA modeling? Which is called auto-regressive integrated moving average. Now what does this mean? That we take a data, try to find out what are the auto regression and moving average in a data. Now let's see how does we. This is auto regression output. It shows that there are two auto regressions. So AR1, AR2 are my two. AR1 is my auto regression. AR1 is seasonal auto 1 and seasonal auto regression 2. Now what is 1 and 2? So AR1 is 1 lag, seasonal auto-regression 1 is 1 lag, and seasonal auto-regression is the second lag. Now what are the lags? Lags are the gaps between the time series data. So it is basically so when you see a time series data, it is divided between lags. Now what we mean by lag? So lag is something, so for example, if today's T minus 1 will be my first lag, T minus 2 is my second lag, T minus 3 is my third lag. So does my today's output or sales depend upon yesterday's or day before yesterday's or day to day before yesterday? That is what it shows about T minus 1, T minus 2 and so on and so forth. So that is what my ARIMA has done. So what I have done, I've told him that, okay, I have one ARIMA function lag 100. So it says that, so ARIMA is AR is this, then is ARI, and then MA. So I say AR1, so it shows me AR1, it comes here. Then I is 0, so I is 0, M, so again M is 0. However, in seasonality, I told AR should be 2, then it should be 1, and then it should be 0. So it shows me 2 AR, AR1, AR2. Now, how did I come to this conclusion? Of course, that happens when you read the data and when we understand further, but we'll also try to see that can we automate the entire process. Right? Now, let's see. So, we saw the output of this ARIMA model, and now let's see, we'll try to forecast. I want to forecast for next 24 months. So, let's see. So, I wrote predict, take the first model, or, conversion with regression, you all understand this. Take the first regression model and go ahead for 24 period. And here goes my forecast data. So, the data weights end, start from there and gives me 24 months forecasting. So, it gives me 24 months, 1961 12 months, 1962 12 months. That's the prediction, and these are the standard error, 95% confidence. So, I'll make this confidence level, U is upper, L is lower, and I take the confidence and make a upper confidence level, lower limit. Now what I do is very simple. I try to plot my test. So I take this, I did the plotting. So the plotting has the original, it has the trend, the forecast, and it also has something called the confidence interval. What are these? These are the things. So I have the original, I have the forecasted, and I have upper bound and lower bound. Now let's see. So that is one example. So let me go to the PPT and see. So we did this. I told you how to make a time series data. We saw this air passenger summary. We made it, converted it into time series data. We saw the trend. We broke it into trend, seasonality, and randomness. We did an ARIMA modeling, which is 1, 0, 0, and 2, 1, 0. We predicted the data. We made 95% confidence level, that is upper limit and the lower limit, and we plotted the graph. So that was my air passenger, and so it will, that 1961 January you will have this much sale. These are all forecast, and these are my upper and lower range. So that is how we tried doing the forecast. Now if you have any questions, you can type it in the question window while we go forward. Right? Now, I'll take one more example for you, and then we'll try to go with a lot of other examples. So, let's see. There's something called an European quarterly retail trade. So, I have one more data set. Now, this last one was monthly. I'll take a quarterly data set now. So, I'll load a quarterly data set, and I'll try to plot. Okay. Now, it's saying that Eurotail is not found. It's not found because I have not loaded the package. So I'll load the package first. Okay, the package would be, let's go to the PPT and do it. All right. So the package is from library. Forecast. So it will take some time to load. In the meanwhile, I will talk about this. So when we talk about this, we'll go with the PPT first, and the moment it gets loaded in my system, we'll talk about, I will go to the R screen and check out ask in proper way. So what is this thing all about? This is about European quarterly retail trade. So we have taken European quarterly data. So it starts from 1996, goes up to 2011 for all the 4 quarters. And we are trying to understand how can we, take out a new trend of this data, right? So what we did, we plotted this and we saw that, okay, it has an increasing trend and it falls down. One of my axes talks about, the year, what are the years starting from, so this starts from 1996, goes up to 2011, and the rate index, right? So what it also talks about something interesting. So let's see, who can tell me what would be the next few months projection look like? So it's going up and then came down. So can someone tell me what would be the next forecast, say just after where the dot end or where the graph end? From there, if I take 2 more years, what would be my forecast look like? So let's have a guess and let's have a understanding and before we go. So okay, let's do it. So there's a couple of people say that it will be upwards. Let's see. So let's see if my I got my forecast package or not. So it's what's saying Eurotail no found. Okay, let's see. It's again showing some error with R. I don't know. Let me check this. Okay, so let's see next. So what I did the time series differentiation for this. So it shows me that, okay, the first part of my data where I take 4 lags, that is go beyond 4 points and show me the data, shows me more of a constant trend. And my ACF and PSCF plots again shows me, a PSCF is partial autocorrelation, and this is autocorrelation factor. PSCF is partial autocorrelation factor. It again shows me something which is okay, which shows me a decreasing trend and so on and so forth. So what I did, I went further. Now what I did a difference of difference. So you take a lag, so you take it lag, say lag 1, lag 2, lag 3, lag 4. Today's T minus 1, T minus 2, T minus 3, T minus 4. Take this data set and again do T minus 4 minus T minus 3, T minus 3 minus T minus 2. So I'm trying to go into more lag kind of thing and try to find out what I'll get out of it, right? So this is what I'm trying to say. So can someone tell me what do you understand by this graph? So let's not go to PSCF graph and ACF graph. Let's try to understand the first graph, which is the graph on the top, the graph which goes across the screen and shows a trend. So can someone, so does your conclusion change after looking at this graph? Till that time, I'll go to R and I'll change this package. Alright, you can see my screen will come here now. So this we did. Okay, this again we did. Now, right. So someone says that it can stabilize, it will go upward. Let's see. So I have some text written. I'll read the text out and then we'll try to understand. There is a significant spike at lag 1. So yes, there's a significant spike at lag 1, which we can see. This is called the first lag spike. There's a significant spike at lag 1 in ACF. Suggest a non-seasonal moving average 1 component. Now, how does it happen? Give you a trick, we'll do it automatic also. We'll try to see an auto ARIMA function also. If ACF shows me a gradual decrease and PF shows me a non-gradual decrease, it's always a moving average. But when a PSCF shows me a very high spike on first lag, it's moving average 1, and so on and so forth. So what we did a 0, 1, 1. 0 was AR. I don't have an AR. I did an first integration and I did a moving average 1 because there's for 1 lag. And I did 0, 1, 1, comma 4. Now what is this 4? I'll show you. So this is first lag. I go down second lag. This is my third lag. This is my fourth lag. After the fourth lag, there's one more spike, unexplained spike. So I feel that on the fourth lag, there is an seasonality. So I gave a seasonality indicator of 4 and I again did a ARIMA function. So 0, 1, 1 and 0, 1, 1. Let's see. So what I did, so this is the same text which I have read to you. So this goes here and it gives me moving average 1 and seasonal moving average 1, because in the last case it was 2, 0, 0. So it was ARIMA, sorry, seasonal ARIMA 1, seasonal ARIMA 2, because it was 2, 0, 0. So the first one was AR and it was 2, so it was giving 2. Here MA is 1, so it's only showing me seasonal moving average 1. Again, I'll try to fit this. So I got my residual. Now what I'll do is I'll try to improve this. What I'll do is I'll just give a hit and trial and tweak the model. So instead of 0, 1, 1, I'll make it 0, 1, 3. So my moving average was 1. So here it was 1. This was 1. Now I'll change this and I'll make it 3. So I get MA1, MA2, MA3 and S8 as MA1. Of course, because my seasonal moving average is 1 and this is 3. Right? I'll add the residual plot and then again see my residual plot. And I'll do a junk box test. So it's again fine with me. Anything less than 10 is fine with me. I'll forecast for next 12 months and use the forecast. And I'll show you a bigger picture in my PPT. So I'll have a bigger picture, I think so, in my PPT. So this is the forecast after I tweak my model. But how do I know this model is perfect? Let's see again. I go further and R do it automatically for us. Yes, there's a command called auto ARIMA. So auto ARIMA would give me an output. It says that you should go for AR1 model and seasonal ARIMA 1 model. So let's see, can we do better? So what I did, I removed the approximation thing. That do not approx, give me the exact thing. And it gave me an exact thing. So let's see what is the exact thing. It is saying go for moving average 3 and seasonal moving average 1. Did it last time. And I did the residual plot, I did the time series data, and you see so if you see the ACF and PCF, it's very, very, very subtle. There's no spikes and there's no decreasing trend or increasing trend shows me that, okay, this is fine. I do a junk box test, it's again fine for me, and I forecast. So this is how I'm forecasting, right? So let's go back to the PPT and see this. So this we did, right? So now we'll move forward to something. Can R do automatically for us? We did an auto ARIMA, but it was more of an approx thing. So I made approx false and told you give me an exact solution. Gave me the exact solution 0, 1, 3 and 0, 1, 1, which was exactly what we did here. 0, 1, 3, 0, 1, 1. This path where I'm moving my mouse. So it gave me the same solution. So my page is good enough for to match the computer understanding. So that was my final model, and this is my final output. So it says that it will decrease. All those who told it will decrease can tap their back and give yourself a treat tonight that you were right. Right. So now there is one data set which is called, there's a Australian drug data set. I thought of that you should do it yourself. So this is the code. Just have to do something. So load a package called FPP, library FPP, and just run the codes which I have given. These are exactly same code, automatic code, and it will give you the sales forecast of the Australian drug. The name of the drug is also on the board. So this is the script. You can go to the recording afterwards and find out and try this script. It's very simple. I first do an auto ARIMA of the data set. Again, no approx, max order 9, that is go up to 9 lakhs. That give me the best model. Go up to 9 lakhs. 9 is maximum. Even 1, 2, 3 lakhs are enough. I go up to 9 lakhs. I don't want to leave any window. Show me the decomposition, do a junk box test, fit the model and forecast. So this would be still running. So it will take a lot of time to run. This is a very huge data set. So you can, at your free time, you can do. Now, what I wanted the next half an hour, I wanted to spend on the course content. Now, before I move to course content, I would appreciate if you have any doubts or you want to ask any particular question from me, and then we'll go forward. Anybody? So, I have a lot of attendees today, so if you want to ask any questions from me, please go ahead, ask a question, and then we'll talk about the entire course content. I'll also take you to, I have an Excel sheet open where I have details of this course content. I'll also take you through that. So any questions, anybody? Anybody? Let me ask you a question. How many of you have ever done modeling? Would you be talking about stock market prediction? Nitin, yes. We will take an example of stock market prediction. So you can talk about anything. So for example, if you take a data set of last 10 years stock market, why don't you try this yourself once and you'll be able to do that. So there's people who have done data modeling, right? So let me, how many of you know regression, logistic regression? How many of you know logistic regression? Come on, let me. Oh wow, great. Now let me ask you a question. So if I have a data set, which is a survey data, my Y variable, the dependent variable, is the rating which I give to this webinar, which ranges from 0 to 5. 0, 1, 2, 3, 5. Right? So 0 is the least, 5 is the best. So, and my other explanatory variables, the X variables are age, name, place of birth, education qualification, my background, number of work experience, and so on and so forth. Would logistic regression be able to predict what rating would I give it to you given the profile you have? So if I tell you that I have a 10 years of experience in data science, I'm 30 years old, I earn X amount of money, I'm from North India, and I know about data analytics, I know these all topics. Would you be able to give me the output, say, what rating would I give to this webinar using logistic regression? Anybody? Would you be able to give me the output? You're a wild guess. Tell me yes, no, anything. Someone says yes. Are you sure? Yes, because I think the logistic regression only deals with two variables, binary. It's either 0 and 1. I have 0, 1, 2, 4, 5. Yes. So what's the way out? Shall I do an ordinary least square regression? Yeah, so all those who says no idea, this module is to get that idea. Anybody? Shall I do, would that be better? But would not that give me 2.5 a number, or can it also give me minus 1.5? So how can minus 1.5 or 2.5 can be a Likert scale ranking? It would give me logistic regression goes from, the output goes from minus infinity to plus infinity. It also gives me a negative value. So what do I do now? So this course would also talk about this. So what I'll do is I'll take you into details of this course. So I'll get my Excel sheet and we'll talk here. So the first module will be the basic statistics in R, which talks about basic statistics in R. We'll talk about basic stats, basic regression, hypothesis test, correlation matrix, covariance matrix, and all this. Second class, we'll talk about ordinary least square method. We'll talk about basic regression, multiple regression, how to export data, connect sheet, basics visualization, again basics. OLS2 would go deep dive. We'll talk about residual plots, overfitting, deletion diagnosis, how should you delete observation to fit your data, partial correlation matrix. So if you have two variables, so for example, if you have my age and my spouse age, and our marital status data. So all these three data would have a high correlation among each other. So which variable should I delete? Why should I delete? When should I delete? So it will also talk about this. It will talk about multi-collinearity. It will talk about variance inflation matrix. It will talk about transformation. Should I go for age, age square, age cube, age square root, income square root, what? How should I do it? Box-Cox transformation. Should I transform my y variable? Should I convert my y variable to y square, square root, or what? So it will talk about all these things also. Then we'll go more deep into ordinary least square thing. We'll talk about autocorrelation. We'll talk about Durbin-Watson test. We'll see that are my residual autocorrelated or not. If my residuals are autocorrelated, what should I do? Shall I also take something called y equal to x, x1 plus x2 plus x3 plus x1 minus 1, that is go back one period, x1 minus x1 minus 3, x2 minus 1, x2 minus 3, x2 minus 4, and also put y minus 1 and y minus 2 also as my regression equation. So shall I go back in time and try to see, autocorrelation? How do I check? Then we'll talk about regression. Then we'll come to something called multinomial regression, Poisson regression, and ordinal regression. These are the regression which will help you to do this Likert scale thing. So when logistic regression 2 and 3, which is advanced logistic regression. Poisson regression are discrete numbers. So population, mathematical marks, subject marks, your age, these are all discrete number. There's nothing called, so for example, if I only give you a multiple choice question, there's nothing called 2.5 as marks. It is all discrete variables. So my Poisson regression. Multinomial, this Likert scale. So if I want to, predict the color of a car, so given a profile, survey profile, what should be the color of the car? Gray or blue. That can be done through logistic regression. But if I have 10 colors, how it should be done? Multinomial. Ordinal regression, ordered data. So if I have ranking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, these are ordinal data. So 1 and 2, it has a numerical value. It is not dummy variable. So how does my ordinal data, how do I tackle my ordinal data? If I take this ordinal data, put it in Poisson on a logistic regression, things will go away because it's just a dummy variable. Here it's not a dummy variable. So how do I tackle ordinal data? Ordered data, ranking data. That would be my logistic regression 2. Logistic regression 3. Zero inflated regression. I have lot of zeros in my data set. Lot of zeros. So there is a called zero inflated regression. Negative binomial data. Panel data. Now what is panel data? I have this time series data. So I have sales for every day for a particular city. I can do a regression analysis. But what if my variable is the day is sales, but I have it city-wise sales? So if I have a city-wise sales, how do I do a regression? So that would come into something called a panel data regression. Panel data is something called cross-sectional data. It is time and space. So I have my time and it has space. So I have Delhi, Bombay, Chennai and Bangalore. So I have these 4 cities. For each day I have these 4 cities data. How do I do it? Okay, so for all the days I have Delhi, Mumbai, Chennai and Bangalore. But in another set, for the first few days I have 4 cities. For the next few days I have 5 cities. For the next few days I have 3 cities. So this number of cities changes. So one is fixed number of cities, one is random number of cities. So what do I do? So how do I tackle this? Again, panel data. Imputations. I have missing values. So I took a survey. People filled their survey. Half of them did not fill their age, but filled other details. So how do I impute the age first and then do the regression? It's about imputation. How to take care of missing values. How to take care of errors. So for example, it has, instead of 23 years old, someone typed 233 years old. So how do I change the data? How do I take care of missing values? How do I make my data, clean my data using different techniques of imputations, and then go forward. So that would be my module 8. Module 9, 10 and 11, 9 and 10 would be, 9, 10 and 11 would talk about forecasting. How do I ARIMA modeling, which I showed you right now, right? ARMA modeling, time series data, seasonality. So we did not do seasonality. Smoothing. How do I smoothen the data? How do I remove trend? How do I remove randomness? How do I remove, noise from the data and make sure that my data is fit for forecast? Instead of that, how do I know that do I need to smoothen my data or not? So we'll talk about seasonality and smoothing. Advanced forecasting, arch and gauge. So if you see a curve, if I have a long tail, long heavy tail, I'll do arch and gauge. I'll do a neural network. I'll talk about growth model. I'll talk about binary data. So if I binary data 01, 01, 01, how do I do forecasting for that? Then I will go for survival analysis. So in a telecom company, prepaid customer, when will they leave my company and go to my competitor? That's survival analysis. How long will you survive? When would an employee leave my company? How long an employee would stay in my company? How long a customer would be loyal to me? Survival. How long will they survive with me? Combine it with data mining. So do a PCA, do a LDA, Fisher model, linear discriminant analysis, principal component analysis, and do a regression on top of it. Even I'll try to add decision tree and then do a regression on top of it. And then we'll talk about a full-fledged case study. We'll take a case study and we'll try to do multiple approaches. We'll take multiple models. We'll do Poisson, we'll do all kind of model and see which is the best model comparison. Then we'll do a project work. Two project. So one project work would be, you will choose your own data set, I'll guide you, you will do the project, and the next time you'll give a presentation. And there is nothing called a wrong answer in presentation, it's all approaches. So this would be the most comprehensive model designing course you'll ever come across. It covers almost all parts. And believe me, if I get time, I'll also cover lasso, rigid regression, I'll cover support vector machines, and if I'm not able to cover, I'll give you ideas of all this. Now take my words, if you do all this, you can learn any machine learning tool and predictive modeling. You'll be so conversant with this. So that would be all from my side. Now before we talk about the system of Edureka, what are the facilities you'll get, let me know if you have a question. I would appreciate a lot of questions at this point of time before we move forward. Yes. Anybody, you can keep typing your questions, and I'll keep answering them. Any questions? Or if you want to, ask something about the course, or maybe something, or if you want me to unmute you, just let me know. If you want to unmute you, I can unmute you and you can speak. So someone is telling, Sachin is telling you are unable to hear. Can you hear me now, Sachin? How to incorporate, so Satish is asking me how to incorporate data modeling with Hadoop. Right, so it's very simple. So depend upon what kind of data modeling in sense, regression modeling and all. So when you have a huge data set, what we do, we break our data set and program into small component using map and reduce thing and try to implement. So I'll also try to cover one big data session with you wherein I'll try to show that how you use R to connect to Hadoop and run your R codes in Hadoop. So that would answer you, that would take care of your incorporating data modeling with Hadoop. So since we'll be doing R, we'll do it using R. We'll use R to get into big data platform, any big data platform, not only Hadoop, and use Hadoop's capability to solve my data set faster. So say last 10 years transaction data would take weeks for me to solve. So I'll use Hadoop with that. So we'll also cover that maybe in one of the last few classes. Does that answer your question, Satish? Right. Anybody else? You should ask me as much question as possible so that you have much more clarity about the course and about the expectations from this course. Anybody else? Any questions? So I see a lot of people typing in. Okay, I got one more. I am looking for data science job and time from you to discuss some real-time questions asked and how to answer. Can you also help in that and how? Navneet, you can type your questions right now, or you can ask, you can post your queries to Edureka and they will send me the questions and then we can take it further. Of course, and if you're doing this course, during this course, half of your queries would get solved. And I would also appreciate you bringing those questions during the class for understanding of everybody, and we'll be able to solve it for everybody. And with better understanding and much more, multiple approaches, what I mean to say. And this one course is the most important for data science if you're looking for predictive modeling. Anybody, let me, if you can raise your hand button also. If you press that, in case you want me to unmute you, I can unmute you. Right. So in the meanwhile, what I'll do is I'll take you to the course structure. If you have questions, you can ask. I'd appreciate a lot of questions. So this will be a live online class sessions. Most of you know that we'll have live sessions. Of course, the recording would be there in the LMS. So if you miss the session, you can see the recording. And if you attend a live session and want to understand it further, again, you can see the recording. We have a 24/7 post-class support. So even if you're practicing at wee hours at night or wee hours and you get stuck, you can then and there raise a ticket with your queries and we'll get back to you with your solution. Every module would have a quiz so that we can see that you are well conversant with the topic and you understand, and if we require some topics to be retaught, recovered, we'll be able to do that. Project work, of course, I told you that we'll have a project work towards the end. However, I'm planning to run it parallel to the course, where in the second or third class only you'll choose your project, and from there onward you'll run it across. And then the certification examination, and the project would also have a presentation which would allow you to have a certification. Certification can be verified using the Edureka credentials. Okay, there's one more question. If a manager comes to you and say the sales decreased to 30% and wants you to tell whether it is correct or not, how to proceed that? So if it looks that 30% has decreased, it must have decreased because you see the number for it. but you can talk about the reason why it has decreased. What you can do, take the entire data set, an ARIMA model or maybe a forecasting model, and see that it has decreased or not, or it looks like it has decreased, right? So for basics, you can do, simple auto ARIMA, check seasonality, check randomness, and go on. However, I'll go further and check for data that are my all data correct or not. If correct, does the right forecasting tool have been applied or not? If it has been applied, do I need to smoothen the data? Does it has, for example, there may be a strike somewhere, or they would have been a major festival and the sales may not have happened, or they could have been election day, people did not come out to shop, and thus there can be a downfall. So I'll try to smoothen the data first and then do the forecasting to take care of all this stuff. Right, Navneet? What format data stored in a DB? Is it binary? It can be any format, any format. Give me any data, we can do anything on this. This course would talk about any data. So Likert scale, multinomial, ordinal, continuous, discrete. Tell me a data, categorical, multiple categorical, anything. So if it is just in real time, anything, real time, historical, anything. We'll play on historical data and try to predict. You want to real time data, you need a very high coding system. That can anything. Means you just need the data set, plug it in, run the model, take the output, and just keep refreshing the model. It can predict what would be the sale next day, how would male and female sale. So for example, what is the effect of Bombay sale on Calcutta, and so on and so forth. Anybody else? Navneet wanted to ask something. Okay, but. So Navneet, you can continue your question, please. I think that would be all. What I'll do is, my screen is here, I'm here available, I'm on the chat. I will switch off my screen, however I'll be on the chat and I'll mute myself. You have questions, you can type, and if you want me to unmute you, you can ask me to unmute you and we can have one-on-one conversation also. Right? So great talking. Okay, I have one more question. If we have to explain them without telling the R algorithm, of course you should tell them the R algorithm, you should tell them the business logic. How should you do it? So you can tell them, okay, there was this kind of thing which came in, there was a strike here, that is why it's 30% sales down. If you remove it, there is no decrease in sales, sales is constant. Or if you say them, okay, the sale has went down, the sale has went down because of this following reasons, or these are the say discounting, your couponing, or your marketing are the reasons because of your sales has are went down. So if I change this, well, you see the sale is going up. So when we talk about this, the entire course, the interpretation would be business. It will never be something called technical at all. Right? Oh, even my H2O2 data set output is out. So the data set which took hours to run gave me the output. It shows me the trend for the next couple of months. Anyway. So this one which I was talking to, that you should do it yourself, DIY. This part. Great guys, so it was nice talking to you. I would love to see you in the class. And if you have questions, please let me know. Thank you and have a nice day and a lovely night. Bye.